Are you gonna like? I have cash. Do you want to make coffee?
Oh my. Okay.
Yeah, I was just gonna like, you're gonna take it, right?
Yeah.
Alright, any song requests?
Is it this?
Play one song and then we're
So you
gonna
play
move on.
just like Hemsley by the Cure?
Yeah, I gotta find and figure it.
No, it's this.
Hold on.
My favorite song of all time.
This
Point
minus.
five. Where'd you play?
The expected?
Yeah, the expected times.
Perfect.
The probability.
Point oh five. Point, no. Point.
Cat, so you're alright. Come up here.
So standard deviation is 0.5.
Yeah. I don't know anywhere. The official.
Yeah,
Wait, how do you
my
get-
favorite lyric of all time for this song is "Found the only girl I love and drowned her deep inside of me," and it's my parents' wedding song. It's just like,
My parents don't remember their Jane wedding song. I keep asking.
my parents had 3 wedding songs, just like Heaven, just like Heaven, Foreigner song.
Standard deviation. What does it say? Carl? Carl?
Label.
Label.
I know, I think it's
Yeah,
cable.
it looks like Carl.
I thought it was
spelled
yeah.
C-A-R-E-L.
Carell.
Carell.
Wait, how are you supposed to find the 99 cups of that? You have to find between. How do you do that?
What's the minus? It's like minus 1 kilo versus
Is it Q norm?
No, because you're finding the.
Well, I feel like we did a really similar problem to this last week.
We always use the like coin flips, that's why.
You know, it's like when you have.
When you have the
Wait, how would you find the mean? Because that can be the standard deviation. The mean is just 0.5, right? So, yeah, that's what I thought.
Would it be Q norm? Because we have
But is it one
Oh,
Q norm
Oh.
with a code and then minus Q norm with another code because you're looking for within the 2 bounds?
My other hint to you is that all distributions are symmetric. So if the red is 95%, what's this area?
5%.
2.5.
Oh, word.
And this is 2.5.
Why would it be
You.
2.5, so it's 2.5.
Wait, is the variance 0?
No.
Wait, but I got.
Ooh.
Nice.
How do you Q norm with stuff? Is that right? No, but that.
So what are you doing?
That doesn't matter anyway. So, right? It wouldn't matter anyway. To get this side of it, I'd do
What you got?
Q norm 0.025, 0.5, 0.05. No.
So
Oh!
It's like
Okay, I found it. You find 97.5, right?
Q norm. Wait, yo, Anna.
100 is 100%.
so you're doing one version of this and then one version.
I don't know. The
This is
variance
not-
is
this is
something
just
weird.
divided.
It's 1 minus 0.5 squared
Is
gives
this
5.
is it minus or is it plus?
But like
97.5.
Regardless
Then
of
it's
that.
0 minus
Minus into parentheses and then plus.
It's
Okay.
one version of one.
Yeah, it's 0.125
Yeah.
times 0.5.
That's for the.
Subtracted, right? Yeah.
Wait,
You know about this part? To get like this standard deviation minus this
no, I
part.
know.
Right?
I'm not.
No.
No, because I'm saying it's, this is point. This is point.
Let me see if it works and I'll come back to it.
Yes. It's literally not even what
Hold on, let me see what I get.
Alright, we done?
No.
So it means it's correct?
0.5 and 1 and 0.5.
5 for 5, yeah.
Row. Yeah.
Come on.
0.05.
Show him.
Don't you have to minus some Q norms?
Aiden, come on, man. Come on, do something, do
I
something.
don't know if this is.
The standard deviation is 0.1875 of the square root of.
So what is Q norm? Give us the value when we,
Percentile.
everything to the left,
Can
so.
you repeat what you put down?
How much is to the left of that right down?
No value.
Yeah.
Can you just do point
In parentheses, square root times 0.5 plus 0 minus 0.5.
one minus
Right,
one
that's right.
And what'd you get for that?
You wanna get, you can
for
put
Q
it.
norm.
Oh, it's 975.
What
Okay,
is it?
you're right.
It's
That's
one
what I was
minus
thinking.
Q norm.
Not one minus.
So you just
Q
subtract
norm gives you a
this
value.
little
so
part.
rather-
It's 0.5
Oh,
squared.
okay,
It's
I meant
0.5
like,
times
This whole
0.5,
thing here
times
minus
0.5.
this whole
Which is
thing.
0.125.
Left of this value.
Yeah, I got
This whole
0.15
thing minus
actually.
this
No,
whole thing.
because you have to include this.
I got 0.1875. As a covariance.
0.9.
So it's
0.9.
95.
But you
0
subtract
minus
that minus
0.5
the-
is negative 0.5
Is it
squared
0.975?
is negative,
Yeah.
or no, it's 0.25, it's 0.125.
All right,
And then times 0.5, right?
one more minute.
0.125 times 0.5.
Is it?
It's
It's like
0.625.
2.5.
It's 0.25 times 0.5. That gives you 0.125, and then you just add that.
Oh, how did I get, wait, point,
Oh, then you.
Yes, the middle
Yeah.
block, yeah. Exactly.
wait, yeah, I know that. I'm just, trying to do
I'm with you.
I put down 0.125, not 0.25.
Because
So,
Because it's not left line, red line.
I wanna make sure I can, so
0.025 and left, right?
yeah, it's
Q
0.5.
norm says you take the area to the left, but it spits out the value.
What'd you get, Casey? Do you have 0.01?
So this should be doing 7.5. Because it's 2.5% to the left, 95% in the middle.
Because this
Squared is 0.25.
is 0.25 times 0.5, which is 0.0625.
So 0.05.
Wait to the left, so is that 1 minus?
0.25 plus.
Nope, not one, so
Minus
don't,
the varsity, right?
because Q norm always just takes the area to the left, and then,
Who would this?
yeah, so plug that,
Okay,
yeah.
so why did you do 0.5,
This is
0.97, 0.25? We know.
Sophie,
Yeah.
alright?
Because you
Yeah.
are
I tried to find the other one.
And if it's even
0.125.
on either side, it's not
It's
5% on
0.125.
either side.
And then on the other side, 0.
Yeah.
Zero,
Yeah.
0.5, negative 0.5. Square that, 0.25. And then you get basically the same thing.
Wait, what did you get for variance?
I got 0.5.
0.975.
We're still working on that.
I
Yeah,
got,
but then how much goes to the other one? Q norm.
I got 0.375.
Oh.
That's a 0.30 answer.
Points.
I don't know why I'm doing
But we
this so weird,
Isn't
baby.
this like such a basic one?
Yeah,
Oh,
I'm
you
just trying to
just
make sure.
So
what does it mean,
you
find
have
95%
Jamie, what's the
bounds?
variance?
You have 1.5.
So I just want like those,
Yeah.
I'll go over.
Yeah,
it.
the answer.
Okay,
Yeah.
I know that makes sense.
Alright, here.
You ready? I'm gonna work this out.
So you have to.
I have to tinkle.
This is 0.5. Square root is
You need to
0.25.
go down instead.
Alright, can we go over it?
It's like a line.
Or you guys making good progress over there?
We did.
I got now.
0.5.
Both of these
Yeah.
equal 0.5.
Literally times 0.5 again.
Yep. Which is 0.125. And then the same thing happens over here. Yeah.
And this is the
And then-
same thing.
Yeah.
No, so
You
you
did
don't want
it.
to subtract it, actually, you want, I just want to know.
And then add
what it
this
is.
together.
value
0.125
right
plus
here.
0.125.
I know it's gonna be 0.25.
What is this value right here?
Oh, so I just figured them out separately.
Yeah.
Is it Q?
Alright, Anna, Casey, Rachel, are we good?
Yeah.
Just figured them out separately.
Alright, let's talk about this, because,
It's getting frustrating because I'm trying to like do the work so I make sure I can do it.
Me and Rachel are working together.
so really quickly,
I got it.
I'm not gonna even go over this, except for I'll go over it. H with probability 0.5, 1 with probability 0.5, 0 with probability 0.5, so the variance of H is equal to what in the end? So 1 minus 0.5 times 0.5 plus 0 minus 0.5 times 0.5. If that's unclear, you're going to have a real hard time on the quiz tomorrow, so please ask questions after class. So this comes out to be what, 0.25? And so what I said, Hannah, about the formula, this is actually P times Q, if this is P and this is Q. If you have a binary 1-0 random variable, it's great that you understand, hopefully you understand the variance formula, so you don't even have to remember it, because you understand why it is what it is. But for the sake of time, at this point, every time you have a 1, 0 random variable, to find the variance, I just multiply the probability of 1 times the probability of 0. But now if I want to find the standard deviation of this distribution, so sigma sub h bar 100, I know that this is sigma sub h divided by what?
The square root of it.
Square root of n. But what is sigma sub h?
It's the variance.
Sigma squared sub h is the variance. So to get the standard deviation of h, I need to do what?
Oh, square root of variance.
Take the square root of this. And so this actually comes out to be the square root of pq divided by the square root of n. If you remember your old algebra 2 days, that's the square root of pq over n. It all works out if you think about it. Don't think too hard about that right now. But so in general here, I find that the standard deviation of sigma h bar 100 is equal to the square root of 0.25 over 100, so that's equal to 0.5 divided by 10, which is equal to 0.05. And so that is something that should be familiar for the quiz tomorrow. If you flip 100 coins, there's a sampling distribution where every x represents a sample of 100 flips. So by the way, in case this is not clear, this thing is kind of this sampling distribution where all these x's represent a sample of 100 flips. It's kind of this hypothetical imaginary thing. We could actually do it. I can flip it 100 times and 100 times and 100 times and 100 times, and then I can start to look at it distribution like this. But the cool thing is we can just know that it's going to come out to be normally distributed without even doing all that work. So the standard deviation here is 0.05. So lastly, because we're going to talk about confidence intervals, and we often discuss, so people with laptops open, if you're using them, use them. If not, close them.
I'm just using R.
Okay. We're going to discuss 95% confidence intervals. So this idea of a bound that has width 95% maybe is going to be relevant in a second. So that's why I wanted to find these bounds. So any idea how I should find this value?
Q norm?
Good. So this would be Q norm of what? 0.975, because I want 95% here, but I also need 2.5% to the left. Just the crucial assumption here is that normal distributions are symmetric, right? So if it's 95, then this is 2.5 and this is 2.5. So 0.975, comma, 0.5, comma, 0.05. And that comes out to what? 0.597.
Why 0.05?
That's the standard deviation of this distribution. So it's the standard deviation, which is the square root of this, but divided by the square root of n. So it's not just 0.5, it's 0.5 divided by 10.
I'm a little confused about how you got
Where do you 10 though?
You get 10 to the square root of 100. Rachel?
I'm a little confused about how you got the 0.975. Like, why that bound?
Because I want...
Because you want the n, like the two n?
I just said I want whatever value here in this distribution corresponds, like, what's the percentile for this distribution of 0.597? What's the percentile for 0.597? Not 95th, the 97.5th. So if, basically, let's round up here.
Did you find that using-
0.597, if we flipped 100 coins, how many heads is this?
6?
Not 6, 100. 60, right?
60 out of 100?
0.597 times 100 is 59.7. So let's round up. I'll just say this is 0.6. So if you flipped 60 out of 100 heads, you know, that is such an extreme outcome. It's in the 97.5th percentile. 97.5% of the time, you're going to flip a number of heads that is less than 60. That's the interpretation of percentiles. 97.5% of the time, you're going to flip some number of heads